The fossil record. You probably already know that fossils are the remains or evidence of once living organisms. Paleontologists are scientists who study the fossils and try to get an understanding of how these organisms lived in the past. The fossil record is made up of all the fossils ever discovered on Earth. It contains millions of fossils that represent many thousands of species. Most of these species are no longer alive on Earth. The fossil record provides evidence that species have changed over time. The fossil record is enormous, but it is still incomplete. Scientists think it represents only a tiny fraction of all the organisms that have ever lived on Earth. The formation of fossils is a very rare event, and it is usually only the hard parts of the organism, such as the bones or shells, that form fossils. Most fossils form when organisms die and become buried in sediments, such as soil, rock, and mud. And when a river flows into a lake or an ocean, the sediments that the river carries settle to the bottom, and layers will continue to cover dead organisms over millions of years, forming hard sedimentary rock. Now, some remains become petrified fossils, which means that when they are buried in the sediment, minerals dissolve in the water and soak into the buried remains. Gradually, these minerals replace the remains, changing them into rock. Sometimes shells or other hard parts buried in the sediment gradually dissolve, and an empty space remains in the place that the hard part once occupied. This hollow space, which is in the shape of the organism or part of the organism, is called a mold. Now, sometimes that mold may be filled in with a hard substance and mineral, forming what we know as a cast. And a cast is a copy of the shape of the organism that made the mold. Some of the most exciting fossils are preserved remains, and these are organisms that can be preserved in substances other than sediments. For example, entire organisms such as huge mammoths that lived thousands of years ago have been found preserved in ice. To understand how living things have changed through time, scientists need to be able to determine the ages of these fossils. Scientists determine fossils' ages in two ways: relative dating and radioactive dating. Scientists use relative dating to determine which of two fossils is older. To understand how relative dating works, imagine that a river has cut down through layers of sedimentary rock to form a canyon. Now, if you look at the canyon walls, you will see layers of sedimentary rock piled on top of each other. And of course, the layers near the top were formed most recently, and the layers at the bottom are the oldest because they were formed years ago. Therefore, fossils found in layers near the top of the canyon are younger than fossils found near the bottom of the canyon. Radioactive dating allows scientists to determine the actual age of the fossil using radioactive elements. Radioactive elements are unstable, and they break down into different elements. The half-life of a radioactive element is the time it takes for half of the atoms in a sample to decay. Scientists compare the amount of radioactive elements in a sample to the amount of the element into which the organism breaks down. This information can be used to calculate the age of the rock and thus the age of the fossil. Using radioactive dating, scientists have calculated the ages of many different fossils, and from this information, they've created somewhat of a calendar of Earth's history that spans more than 4.6 billion years. Scientists have divided this large time span into smaller units called eras and periods, and its calendar of Earth history is known as the geological timescale. Okay, it's time to show what you know.